Hello viewers, welcome to Senior College Mathematics. Topic of discussion is bearing. Lesson 3, location of a point from another, that is reversed bearing, part 1. In this lesson and others, we are going to examine practical bearing problems. Examples, number 9. If the bearing of A from B is 125 degrees, 3 kilometers, find the bearing of B from A. In practical bearing problems, one key word you always watch out for is from. The word directs you to know where to start from. In this question, the bearing of A from B, you locate the bearing of A by going to point B. That is the meaning. So let's take somewhere here as point B. The bearing is 125 degrees. In clockwise notation, you start from the north because it is 3 digits. So from the north to this point, you have 125. The distance is 3 kilometers. You draw it 3 kilometers. You draw it to scale, and here you have point A. So this is point A. So from here to here is 125. Now, to get the bearing of B from A, you have to go to A and start movement from the north till that line that joins B and A together. This other angle is not needed, so you have to subtract it from the 4 quadrants angles, that is 360 degrees. So let's try and get this angle. To get this angle, you need to get this angle. Remember, the whole of this side is 180 degrees. From here to here is 125 degrees. So this other angle must be 0.55 degrees. So that when you add it, you have 180. This angle also becomes 0.55 degrees. Alternate angles. To get the bearing of B from A, you have to subtract this angle from 360 degrees, and that is 305 degrees. The bearing of B from A, you go to the north where A is located, and you start movement till that line that joins B and A together, and you get the required bearing. Example 10. 3 cities are on the same horizontal level, and the bearing of city A from B is 0.60 degrees, 4 kilometers in distance. Then city C is 3 kilometers on a bearing of 150 degrees from city B. Draw a diagram to represent the above information and calculate the distance between city A and city C. Solution. You have to analyze the question carefully. Look at the first from city B, that is A. Look at the other one from city B, that is C. So cities A and B are from city B. City A and C are from city B. That means city B is the focus in this question. That is one point. Secondly, consider their bearings. The first one is 60 degrees. That is the first quadrant if you are moving clockwise direction. Then 150 degrees, that is the second quadrant if you are moving in clockwise direction. So you know how to locate city B. Let's take for instance, you decide to locate city B here. So 60 is to city A. 150 is to city C. That means you have city C outside your notes or your writing material. So city B should be somewhere here so that you can create space to city A and city C. All right. So let's continue. So this is city B. So let's take city A. The bearing is 60 degrees to somewhere here. So you have city A at this point. The distance is 4 kilometers. Distance is 4 kilometers. So from here to here is 60 degrees. From the same city B to C is 150. That is, this is the first one. Now this is the second one. Here is 150. So let's draw it somewhere here. Remember that the distance is 3 kilometers. So city C cannot be the same level with city A. So let's extend it and label this as city C. This is city C. Then here you have city A. You can join both cities together. So the diagram for this question should be something like this. So this is 4, this is 3. So you are asked to get this side is unknown. To get this side, here you have 3 options. You can use sine rule, cosine rule, or Pythagoras rule, depending on this angle, the angle that is opposite the unknown side. Now, from here to this point is 60 degrees. From the same knot to this point is 150, and we are interested in this angle. This angle must be 90 degrees, because this angle that is opposite the unknown side is 90 degrees. We can use Pythagoras rule, because now you have a right angled triangle to get the unknown side. We have the complete diagram. This is city B to city A. The bearing is 60 degrees, and this angle is equal to this angle. The distance is 4 kilometers. From the same city B to city C, the bearing is 150 degrees. I've already explained why here is 90 degrees. That is 150 degrees minus 60 degrees. The whole of this side is 180. From here to here is 150. This remaining angle must be 30 degrees, which is equal to this angle. Next thing is to label. In triangle ABC, this is angle C. The side facing it is small letter C. This is angle B. The side that is facing it is small letter B. This is angle A. The side that is opposite angle A is denoted by small letter A. Since angle B is 90 degrees, we can get this side the distance between city A and C by Pythagoras rule. In triangle ABC, use Pythagoras rule to find distance AC, denoted by small letter b, since one of the angles is 90 degrees and the side that is facing the right angle is the longest side or the hypotenuse. And the rule states that the square on the longest side is equal to sum of squares on the other two sides. So b squared is equal to 3 square plus 4 square, and that is 9 plus 16 equal to 25. B becomes square root of 25, and that is 5 kilometers. Example 11. The bearing of a fig tree from a tower 20 kilometers is 185 degrees. If a man is 25 kilometers on a bearing of 335 degrees from the fig tree, find the A part of the question, distance between the man and the tower, B, bearing of the tower from the man, C, bearing of the man from the tower. Solution: let F represents the fig tree, T represents the tower, and M represents the man. From this question, we have two key positions: the bearing of the fig tree from the tower. So from the tower, you move to the fig tree, and the bearing of the man from the fig tree. From the fig tree, you move to the man. We have to consider the given angles: 185 degrees, 335 degrees. This angle is 3 digits, and you must move from the north. If you move from the north, this angle will be located in the third quadrant in clockwise direction, while this angle is in the fourth quadrant from clockwise direction. Okay, so let's start from the other part, the man from the fig tree. If you decide to locate the fig tree somewhere here, it means you will have the man towards this direction. So if the fig tree is too close to the left margin of your writing material, it means you are going to locate the man outside your writing material. So let's have the fig tree somewhere here. The bearing of the man from the fig tree is 335 degrees. That is the fourth quadrant in clockwise sense. So from here, you take it to the man. You see that? So if the fig tree now is at this point, you will be drawing the man outside your writing material. So you must be very careful when you are carrying out this analysis. So we have somewhere here the position of the man, and the distance is 25 kilometers. Let's come here. The bearing of a fig tree from a tower is 185 degrees. That is the third quadrant. The tower is connected to the fig tree. For us to have the third quadrant, that is somewhere here now, this is the third quadrant in clockwise direction. So we have the tower somewhere here. Here should be the position of the tower, so that you have 185 degrees and you join it to the fig tree. Then you can close this part as well. So this whole angle here, 335 degrees, you need to get this angle which is equal to this angle. This angle here is 185 degrees, so this other angle must be 005 degrees, which is equal to this angle. We want to get the whole of this angle. If from here to here is 335 degrees, this other angle, to make it 360, must be 25 degrees. So here is 025 degrees plus here 005 degrees. This angle becomes 030 degrees. Here is 20 kilometers, here is 25 kilometers. In order to find the distance between the man and the tower, this distance, you need this angle, so that you can use either sine rule, cosine rule, or Pythagoras rule. But in this case, you cannot use Pythagoras rule because this angle is not 90 degrees, it is 030 degrees. You have the complete diagram. I've already explained how this angle came into existence. So you label the side in triangle MTF, angle F. The side facing it or opposite it is F. This other side is T. This other side is M. So this angle is 25 degrees equal to this angle. Here is 005 degrees. From here to here is 180. To this point, 185 here becomes 005 degrees, and it is equal to this angle. This angle plus this angle is 030 degrees. We are asked to also get the bearing of the fig tree from the man. From the man, you have to go to the man. You start from the north to that point that joins the man and the tower together. So we need this angle. If this place is 025 degrees and all of this side is 180, we need to get this angle, so that you subtract the sum of this angle and this angle from 180 for you to get the remaining angle. So let this angle be theta. You have to get it. You are also asked to get the bearing of the man from the tower. You have to go to the tower and start movement. From the tower, you start movement to this place, the line that joins the tower and the man together. Already from here to here is 185 degrees, so you need this angle denoted by beta, so that you add 185 degrees to beta. That is the bearing of the man from the tower. A part of the problem, distance between the man and the fig tree is empty, that is equal to F, and is by cosine rule. In terms of the three letters F, M, and T, you state the cosine rule in this form. So F squared is equal to 20 square plus 25 square minus 2 times MT, that is 2 times 20 times 25 times cos F, and angle F is 30 degrees. When you evaluate, you have it in this form, then this result. After subtraction, you have 159. To get F, take the square root of both sides, and F is equal to 12.609 kilometers. B, the bearing of the tower from the man. I have already explained this, that the bearing is 180 degrees, minus theta minus 0.25 degrees. And looking at the triangle MTF properly, you can obtain theta using the sine rule. You know, to use the sine rule, you need one complete side. Now, we know side F and we know angle F. For us to get theta, the side facing it, M, is given. That is 20. You state the sine rule in this form. You replace what the other three sides stands for. If you make sine theta the subject first, you have to cross multiply and divide by this coefficient. You have sine theta equal to this. Sine 30 is 0.5. That is the value you have here. So after division, you have this result. To get theta, you take the inverse of sine of both sides. When you do that, you have theta to be approximately equal to 52.5 degrees. So bearing of the tower from the man is 180 degrees minus 0.52.5 degrees minus 0.25 degrees, and that is 102.5 degrees. The bearing of the man from the tower, as I said earlier, is 180 degrees plus beta. So you need to get angle beta in triangle TMF. In triangle TMF, we know two of the angles, and if you add the three angles in the triangle, the sum is equal to 180 degrees. We know theta to be this, so you replace theta with what it stands for in this form. If you add the like angles in the left hand side, you have this result. To get angle beta, you transfer this to the right hand side. Beta is equal to this, and that is 97.5 degrees. Therefore, the bearing of the man from the tower is 185 degrees plus beta, which is 97.5 degrees, and you have 282.5 degrees. Example 12, an insect moves from a point A to a point B, a distance of 30 meters in the direction 040 degrees. It then changes direction when it gets to B and moves to point C in the direction 150 degrees. If the point C is due east of A, find the A part of the question, distance of the point C from the point B. B, distance of the point C from the point A. Solution. This question is very simple. Let's have the point A somewhere here. The insect moves 040 degrees to point B. So this is point B. The distance is 30 meters. When the insect gets to point B, it changes direction and moves to point C 150 degrees. That is somewhere here. But you must take note of the fact that point C is due east of A. So point C should not be above or below the east of A. So let's drop the east of A so that we know where exactly point C should be. So you take it to this point. This is C from B now. So you have it somewhere here. So this is point C. This angle here is 40 degrees, which is equal to this angle. This remaining angle is 50 degrees now. 50 plus 40 is 90. If from here to here is 150, remaining angle must be 30 degrees, so that here is 070 degrees. So if here is 070 degrees and this is 50 degrees, this angle must be 060 degrees. Here is 30 meters. So this side is complete. We can use the sine rule to get this distance and this distance. You have the complete diagram. This is point A. You have point B and point C. From here to here is 40. The whole quadrant is 90 degrees. This remaining angle must be 050 degrees. This angle is equal to this angle, 040 degrees. From here to here is 150 degrees. This whole quadrant is 180 degrees. This remaining angle must be 030 degrees, so that this entire angle becomes 070 degrees. In a triangle, the sum of the angles is 180 degrees. If here is 070 degrees, you have 050 degrees. To have the 180, this angle must be 060 degrees. So angle C and side C are known. It's a complete side. We can use sine rule to get A and to get B respectively. A part of the question, the distance of point C from point B, that is A, is by sine rule. In triangle ABC, you have the sine rule in this form. You always state the sine rule along that complete side, that is side B and angle B. You replace the known side with what they stand for, cross multiply and divide through by sine 60 degrees to make A the subject. After evaluation, you have this result. You multiply, you have this. After division, you have 26.5357. To the nearest meter, you have 27 meters. B part of the question, the distance of point C from A, that is B, is by either sine or cosine rule. But by sine rule, you have it in this form. You replace the known side with what they stand for, cross multiply and divide both sides by sine 60 degrees for you to have B standing alone. After evaluation, you have this result. You multiply, you have this result. After division, you have this result. To the nearest meters, the distance of point C from point A is approximately 33 meters. End of lesson 3. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the Lord Jesus Christ and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Be good to yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.